Good morning, everyone. Thank you very much for having me here. Thank you very much for the invitation. J'ai oublié de te redemander, tu m'as dit 30-40 minutes. Okay. So I'm very happy to be here today. It's my first time here. I'm very happy to be here to present an overview of. It's actually not my own research. It's a collaborative research project involving a lot of people. And doing research and field work in the central part of the main Ethiopian Rift since 2007. So I'm just going to present some general aspects of this research. And I don't know how many of you are familiar with the archaeological record of the Horn of Africa and Africa in general. So I will just start with some generalities regarding the context. You're probably familiar with Ethiopia and Eastern Africa in general because of the exceptionally long archaeological record we have there with some of the oldest stone tools and archaeological sites on Earth. And on the other end of the story, very recent stone tool production. So we have in Ethiopia more than 2 million years of archaeological record, and it's famous for that. And a lot of people focus on the earliest periods, the emergence of hominids, the emergence of stone technologies, and it's a bit of a paradox, but there are less people working on later periods, on the late Pleistocene and Holocene prehistoric periods in the area. It's a bit Europeocentric, like and I think like researchers are very interested in the area for the beginnings, but once humans are widespread. And in every corner of the world, they are less interested in what's going on in the area. And we have a few people working on that and more, and I'm glad about that. We know that it's interesting to describe and understand the archaeological record of the area because we, as archaeologists, want to understand the diversity of adaptations and cultural behaviors that developed worldwide all over the record, and also this area can give us complementary and different information regarding similar periods that we are focusing a lot in other parts of the world. So we are working in the area with this project with the aim of understanding what happened during this period, which is once again less understood of the late Pleistocene and Holocene. This paper here is to illustrate also that, of course, we always see the area as the core area of people spreading in other parts of the world, and we know that it was actually a bit more complex with opposite flows of people and even people going back to the continent. When we deal with the archaeological record of the area, we use terminologies that were coined. It's a more recent drawing, but that were coined more than a century ago in Southern Africa, dividing the record into ESA, MSA, LSA. So I'm going to talk about the later Stone Age and focus on the later Stone Age, but I will try to show quickly that the term itself poses a lot of problem because of its history, because it was defined a long time ago when we had a poor understanding of the archaeological record, and because the archaeological record itself is a bit more complex. And we often describe sites or industries as transitional because they feature mixed attributes of classic Middle Stone Age, later Stone Age, like for instance, Levallois technologies and backed pieces, microlights. So we have because of the names we use and the labels we put on the sites and industries, we have a poor understanding of the general framework. And a lot of people from different parts of the world are involved in the field doing research in Ethiopia, and they all have different views of this issue. And as a result, it's very difficult to understand each other, and and very few people actually talk about the same thing when they use the same terms. Of course, this period of the later Stone Age is known for the emergence of specific traits that are often associated with modern human behavior. And you're all familiar with this, but it's kind of tribute to Salim al-Brati. It was stated a long time ago now that the archaeological record is much more complex with gradual emergence of several traits. And this is a paper much more recent that also show that using a map to show the diversity of trajectories on the continent. And you all know that one of the main reasons is when we talk about Africa and the archaeological record of Africa, we're actually talking about a huge continent. And you see the scale of the Horn of Africa, Eastern Africa, is actually the size of India. So there are no other places on Earth where we would, put in the same altogether industries separated from thousands of kilometers, and just trying to compare them and say and trying to find similar traits. We don't do that in other places. But in Africa, it's East Africa, it's Eastern Africa, and we all feel we always compare things, and we sometimes compare things between the Horn of Africa and Southern Africa, and it's actually a continent with great diversity of terrains, landscapes, floras and faunas, and so on. Just so you have it in mind. And it's also, unfortunately, it's an area with a lot of archaeological sites, very interesting archaeological sites, but with huge areas where we have almost nothing. And you see that it's only the main sites. I don't have all the sites here, but you see that most of the archaeological sites that we know are located either along the Rift or the Mediterranean area, the Nile River, and Southern Africa, in the coast of Southern Africa. And you see here that we have a bias of site representation, because sites were well preserved, are well exposed and easy to access in the Rift, and in the coast of Southern Africa. We focused a lot on those areas, and we still don't know very little about the archaeological record of the central rainforest of Central Africa. And it's also obvious because we just have one part of the record. And this is true. I'm going to focus on Eastern Africa. This is true also in Eastern Africa. So the colors are referring to periods. So Miocene, Pliocene, and green you have Pleistocene sites. The lighter greens being the late Pleistocene, and the other one middle Pleistocene, I think. And you see that most of the sites that we know are distributed along the Rift Valley, with a few exceptions around. One key aspect also of research in the area is, you all know that, but research started later in Africa and Eastern Africa than in other parts of the world, and especially Europe. You have first collections from the late 19th century, but archaeological research really started around the 1930s, 1940s, with pioneer work of, for instance, Desmond Clark and Paolo Graziosi, who did a lot of interesting things, but who were more focused on building cultural history with tool typologies and a little interest in the stratigraphic context. Research actually developed more around the 60s, 70s, with the development of interdisciplinary research project in the Rift. I give you here some example, but unfortunately, the historical history of the area with political unrest at some moments conducted some stops and gaps in the research, and as a result, this is what we know at the end of the 80s in terms of later Stone Age site. We have like 20 radiocarbon dates back in 86. When you compare for an area which is Ethiopia is twice the size of France, so you have probably something which is about the size of Spain and France together, and you have 20 radiocarbon dates in 1986. And this is a much more recent inventory. So we have a few sites, but if you focus only on the ones which are securely dated, you see that we have a very limited archaeological record. So the Horn of Africa, Ethiopia, is famous for a lot of things, but you have to keep in mind that we know very poorly recent periods, and we are still in a kind of infancy of the research, trying to just describe the material culture and behaviors on the site to try to build a general framework and understanding of the period and the area. So this is, and this is also a tribute to John Sutton. This is why, with this in mind, that we started this research project. It was initiated by Professor François Blanc from the University of Toulouse in 2007, and we focused on an area of the central Ethiopian Rift. Was very interesting because we knew there were sites described there before. We knew there were a lot of obsidian outcrops, very large, high quality obsidian sources. Important lake systems that would allow to test the importance of lake systems during later prehistory, and well-developed alluvial lacustrine sediments that would possibly offer good preservation conditions for the archaeological sites and preservation of organic material. So it's so here is a focus you see on the top right. So the Ziway-Shala Basin is nowadays formed of 4 different lakes that are closed drainage, which is nowadays separated from the drainage of the Awash, but that was part of the same drainage at some moment during the past. It's a large system, very well described by geologists since the 1960s. And it's actually very interesting because we know that water level used to be much higher at different time during the late Pleistocene and Holocene. And the 4 small lakes that we have nowadays actually used to be part of a single larger lake. See here at the bottom, which was very large. For those who are familiar with Ethiopia, this is larger than Lake Tana, which is nowadays the largest lake in the country. So this is an area very interesting because it's called by paleoenvironmentalists amplifier lakes. We are at the floor of the rift with important elevations on the side of the rift and a lot of rainfall. So it's located in a very dry, flat area, but it's very sensitive to climate changes and changes in rainfall with rapid changes in water level. So this is what you see here with several ice stands in a very short period of time of 15,000 years, and you see that it's fluctuated a lot, and it's a very interesting area to test human environment interactions in lacustrine landscapes. So the team grew over the years with different specialists involved. And we surveyed a lot because the area of we focused, because we have different kind of contexts in the area, but we focused on the Bulbula River valley, which is a short valley of 30 kilometers long, with accumulated hundreds of meters of exposures. And we spent a lot of time, walking and looking for paleo soils and correlating those and sampling, testing some of them for the archaeological record and radiocarbon datings. So here is the valley, and you see actually that we focused on several areas, and especially two localities, which were more interesting because they actually were areas where meanders were cutting the valley, the main valley, and where Paleo Valley would be exposed. So we focused on those two localities, and also in a very different context, which is not far, a rocky volcanic outcrop in the plain that has a totally different record than the fluvial and lacustrine sediments. So once again, so I'm talking about a work that lasted more than 10 years. But we spend more time working and drawing the profiles and trying to correlate things than really excavating. The goal was to understand the history of the valley and the location of settlement of humans along the valley. And as I told you, you have accumulated several hundred meters of sediments with cuttings. When the water level dropped, materials were removed, and when the level raised again, you had more. This is what you have on the drawing here. You have more sediments deposited, and of course, the course of the river changed through time. So it's a very complex sequence. Fortunately, with little vegetation cover and easy access to the profiles. As a result, we are able to identify two main periods with human presence in the valley at the very end of MIS3 and at the border between the late glacial and early Holocene. And we have almost nothing for all MIS2. What we have during this period is a lot of volcanic events with numerous thick pumice deposits. So we don't know if people were not in the area because of the volcanic events, but you don't have volcanic events for 20,000 years in a row. And we have paleosoil, so we have at some moment stability. So we still don't know why we don't have evidence for human presence during MIS2. And also, paradoxically, during the early Holocene, when the water level was very high, people had to move to the margins of the lake. So we don't have we have deep lake sediments in the valley, but we don't have human presence. So the two moments that we were able to describe are the late MIS3 and early Holocene. With different context. You see, unfortunately, this is a very interesting paleosoil dated to 30,000 years ago. But it's at the foot of dozens of meters of very unstable sediments, so it's never going to be possible to conduct a proper excavation there. So what we do is very limited test excavation, cleaning profiles, but to make sure to collect controlled samples in stratigraphic context. And there we are able to describe a very interesting industry of a Levallois method with a very with elongated blanks and end products that are kind of typical of the area of late MSA, late MIH3, with points, with base thinning retouches on points and things like that. I'm not going too much into the details. If someone is interested in a specific aspect of the lithics, I'm specialized in lithics and I worked on the lithics for the project. So and for my PhD. So if you're interested in lithics, I can tell you more. For the late Pleistocene, we have things very different, different context, well preserved, with blade and bladelet industries, and also different. So this is another locality, Dekawede 2, and you see that we have in a very small area a nice series of paleosoils that allows us to describe in detail the transition between the late Pleistocene and the early Holocene. You have here alluvial and lacustrine deposits of the water basin raising progressively. So you see the dark sediment here is dated of the very end of the Pleistocene, and the paleosoil above are dated of the very beginning of the Holocene. So in some specific areas like this one, we are able to discuss in details the shift that took place between the Pleistocene and the Holocene. So it's a close-up view, and there is some part of the figure is missing. I'm not going into the details. It's actually a bit complicated in terms of recommendating because of the plateau before at the beginning of the Holocene. But to show you the difference between the two industries and context that are very close in space and very close in time. So those are the fauna remains from DW2S2, which is the late Pleistocene site, with only medium-sized bovids and dry adaptated ungulates such as the Damaliscus ipsodon. And when you shift to the early Holocene, you have all of a sudden a very important use of lacustrine resources, presence of a lot of fish. So it's quite rare and interesting for us to be able to describe such a change and to correlate it with material culture. And you see that in terms of lithics, you will have also very different type of industries. So this is the late Pleistocene one, with also specific actual dart with triangular base made on a narrow bidirectional cores that are kind of reminiscent of naviform cones from the Near East. And on the other side, for the early Holocene, you have a very different industries of micro bladelets. This is the scale. This is a 1 centimeter scale. So you see that you have very small bladelets made from berylline cores or other modalities, and that are retouched, pointed micro bladelets. We still don't know what they were doing with them. We tried to we did some user analysis, and we still don't understand what was the purpose of doing this. Those bladelets were produced by pressure flaking. So it's also probably the earliest documented evidence for pressure flaking in the area. Of course, it's a very basic modality of pressure flaking. It's not the production of a large product, but it's also interesting. And a lot of when we focus on a small area, we have we just have an overview of all that remains to be described in the area. This is an example of larger bladelets from the early Holocene. We are happy to have the possibility at some of the sites in the area to correlate changes in human subsistence strategies with lithic traditions, and you see that you have very distinct types of stone tool production at the end of MIS3 and at the late Pleistocene, early Holocene boundary. But unfortunately, we have this gap in the archaeological record, and we are still not able to address the issues of the emergence of bladelet industries, of backed implements, and such kind of things which are of interest for the researchers in the area. We are also able to correlate the changes in lithic technology with the different sources of raw material. So this is an overview of all the different obsidian samples that we analyzed through mass spectrometry, and that allow us to actually map volcanic flows and the overlapping of several volcanic flows. And this is something you can do with obsidian. You don't have one obsidian source for a volcano, you have an obsidian source for a specific flow. And in this area, we have a chance to have dated flows. So we know that this one, for instance, is younger than the LGM. So it's very interesting also to cross-check our chronological sequence and to document the geographic range of the different groups, different periods, because we can very precisely pinpoint the materials that were used at the site. And it's very interesting because so we also analyze stone tools, of course, and we are able to to make some groups of with the different flows and to document the change through time and the emergence of the use of flows that were non-existent or unused before. And what is also very interesting is that we document the use only of local raw materials. The radius of the area with the different sources identified is only 50 kilometers. So it's very, it's probably because you have huge quantities of very good quality obsidian everywhere in the rift. But compared to the late Paleolithic archaeological record, and you have a very different situation with the use of local resources. So as I said in the beginning, it's interesting because that gives you a contrasted view of what were the human behaviors during this period. Because we probably have a different, we probably have in other part of the world very different conditions of access to raw materials during this period. And what we did recently, I told you about this rocky outcrop in the plain. There, because it was not within inside the lake and not and that a human could settle there regardless of the water level and the situation in the water basin. So there we were able to identify materials from MIS2 and to want to bridge the gap between the two industries. Unfortunately, some part of the context is not very good. We are in a rocky environment, and you all know that it's sometimes a bit complicated. But we still have at the bottom well-identified stratigraphic units where we have the co-occurrence of this late MIS3 tradition with Levallois elongated products, but also with the presence of a few small backed bladelets. People are still working on this. We have colleagues who worked on. I didn't work myself on this site, and the paper is still in preparation. but maybe depending on the status of this industry, maybe we have also here the chance of catching some kind of transitional, even if I don't like the transitional term because it doesn't say nothing, but at least a point in the archaeological record to describe this change. I told you about surveys we did in the plain. What is also important, and an important part of our work, is Ethiopia is a country developing very fast. So we are also surveying sites that are destroyed because they need materials for road constructions and so on. And we are able to identify new sites and to complete the archaeological record we have. I'm not going in detail, but we have a lot of work ahead of us, trying to precise some of the datings, because we now have a good chronological framework with direct datings of premises, with argon datings and radiocarbon dating on organic materials. So we are very we have an accurate dating when we are dealing with volcanic materials, with organic materials. But the problem we have, and I don't know why the figure is like that, is when you look at the shell materials, when you want to precisely date the ice stands of the lake, the material that you have are shells, and we have probably organisms consuming old carbon with a lot of reservoir. And we have a lot of problems when we try to date the lake ice stand. So there is this is one of the problems we are facing now. 5 minutes, tranquille. What we are going to do in the next few years also. So I told you that the drainage was sometimes related to the Awash Valley, sometimes not. So what we want to do, what we were supposed to do this year, is to work at the contact of the two drainage and try to see if we have a different geological history, and if we have similar patterns in terms of material culture and settlement in this part of the area. But what I wanted to say is that what we were discussing about earlier is that unfortunately the situation is complicated in Ethiopia. And last field work we were able to conduct was in 2019. That was the COVID, then the war. This is a picture of the hotel where we used to stay in Ziway, that was burnt down in 2021. I was supposed to go back to the field like a month ago, and we had to cancel 3 days before. So that's why I'm talking using the past. I'm still hopeful that we'll be able to return soon, but it's a sad situation, I think, and I'm more saddened for the people living in the country than me not being able to go there for field work. But it's also part of research in the area. Is sometimes you have long pauses and gaps in research because of the situation, and this is also a good example. Fortunately, we're still able to work on the materials, the samples that we have, and to go back to Addis Ababa and analyze the lithics and fauna remains. But we are, for the moment, not able to go back and survey for new sites. Thank you very much.